Welcome to Industrial IoT Live Lab here on Industry4.tv. This is a series of weekly live shows where we get to explore tools and techniques for building the connected factory. So if you're new to this channel, please make sure to subscribe and then click on the notification bell to avoid missing any of the episodes. So today we will explore a cutting-edge open source framework for smart manufacturing, which is called Factory Plus. So Factory Plus was developed by the Advanced Manufacturing Research Center at the University of Sheffield in the UK. So just a quick note here, today's show is actually pre-recorded. I'm currently away for a speaking session. So if you have any questions, please feel free to leave them in the comment section and I'll get them to them as soon as possible. Okay, so let us get started. So the reference framework that we're going to be talking about here again is the Advanced Manufacturing Research Center, Factory Plus. So that's the website that you can go to check out this reference framework. So what we're going to do here, we're kind of like going to give you a high level overview of this, but for more detailed and more in-depth understanding of the framework, please feel free to check out this website. So we're going to be going back and forth between the slides and the website to do some referencing. But basically, the idea here is to kind of like break down this into some manageable or understandable information for you to then explore on your own. But this really is a very impressive and interesting framework. So that's why we decided to kind of like bring this for you as part of our series here on Industrial IoT Live Lab. Okay, so now, according to their own definition, Factory Plus is a cutting-edge open source reference framework that establishes the digital blueprints necessary for the state-of-art connected manufacturing facility. Now, first of all, let's kind of like take a look at what really Factory Plus provides as far as this reference framework is concerned. Now, Factory Plus is this open, adaptable framework that has completely reimagined data management in manufacturing industries. Now, imagine a solution that deals with everything from data extraction and transport to storage, processing, and security, kind of like defining a specification for all those crucial components in a smart manufacturing setup. So you could think of Factory Plus as sort of like a Lego kit of interconnected parts that sets the stage for an Industry 4.0 architecture that is perfect for really building a connected factory of today. And the interesting aspect of Factory Plus that I greatly appreciate, which we'll discuss more of in a bit, it takes the approach of connecting components to an infrastructure rather than connecting them directly to each other. So again, we're going to talk in detail what that really means. But basically, what Factory Plus provides is a unified approach to 6 key elements, which is data extraction, how to get data out of devices, PLC, or equipment, data transport, how to move that data after you've extracted it, data storage, standardizing on how to store the data, data processing, how to process that data, and then data consumption, how to make that data available for consumption by all the different or interested components within a smart manufacturing architecture. And then obviously data protection is a key issue as far as security is concerned. Now, but what's really cutting edge about Factory Plus is this forward-thinking approach to understanding the importance of having a strong architectural base. which is something that I see is missing in a great deal in the industry. There is a lack of a strong foundational architectural foundation that really kind of like sets the stage by specifying on all these key areas that you need to take off as an engineer if you are building an industrial IoT solution. So by taking this approach or by making this available, this really makes it easy for engineers to focus more on problem solving rather than on data management, because the situation currently is that you find a lot of engineers or a lot of personnel kind of like spending valuable time on the data management aspect of it. Sure, that's important, but it would be so much easier to kind of like have that taken care of, that already specified, and then you can only focus on delivering value or just getting instant access to that standardized data and only perform or make it useful in areas where it makes sense for you to use that data. Now, before we move on, there is also another aspect that I need to point out to you here, as you will notice later. So Factory Plus uses an MQTT Sparkplug pipeline as its communication backbone, but it also uses protocols like OPC-UA for communication between industrial devices and for accessing raw process variables from field equipment and then ingesting them into an MQTT Sparkplug pipeline. Okay, so now Factory Plus is a great abstract conceptual framework, but what's more impressive is that the folks at the AMRC, the Advanced Manufacturing Research Center, they really took it to the next level by making a more practical, right, developing a more practical solution that implements this abstract framework, and they call it the AMRC connectivity stack, or ACS for short. So ACS is like a toolbox which has got all your open source services that the AMRC crafted to help implement the Factory Plus framework from start to finish. Now, the best part about that, of course, is that it's quick to set up, so you can deploy the AMRC connectivity stack onto an existing Kubernetes cluster in literally like seconds using a Helm chart. And that's all that you'll need to do to actually get this Factory Plus rolling. So I'll quickly show you the GitHub repo for the AMRC connectivity stack. So there's all the installation instructions about how to deploy this connectivity stack into a Kubernetes cluster. So again, feel free to check out this GitHub repo and go through all the stages and steps that you need to perform for you to successfully deploy this connectivity stack. Now, there are three foundational principles that Factory Plus uses as the pillars of the reference framework. And these are edge-driven, infrastructure-centric, and report by exception. So, I mean, if you have been following along through conversations around unified namespace and so on, you would have noticed that these are also what advocates like Holker Reynolds talk about as being the minimum technical requirements for a unified namespace. So this is sort of like the version that AMRC uses as the four foundational principles for their reference framework. Now, let's kind of like break down each of these and really talk about what it means for these four foundational principles. So the first one is edge-driven. So edge-driven is basically a data exchange mechanism whereby instead of data being pulled from a component by a third party using a request response polling data, now instead of that, data is actually pushed from the edge, from the component that is producing that data. Whenever that data is ready, it is pushed from the edge into the infrastructure. So that's really a different way of approaching it, as opposed to having like a central server or a central master, as it were, that kind of like requests this information as and when it feels like it should make that request. And really, edge-driven is a game changer, especially when it comes to industrial IoT. First of all, it's because it really cuts down on latency, right? This means that you get faster response times, and you have got the ability to make real-time decisions. You can really create a responsive application that only responds to events as they are pushed from the edge, as opposed to kind of like really always looking out to check what is the current status of all your events to get a notion of a real-time visibility of your solution. Now, another benefit of this edge-driven approach is that it's energy efficient, right? Especially if you're using devices that are constrained, you've got as far as computational resources are concerned. So with edge-driven, there's no need, again, to constantly pull data, so which means that devices can really save on energy when there's no new data to share. And also this approach of edge-driven really lightens the load on a central server or a control system, which means that you get better overall system performance and stability, because here obviously we're talking about less strain and more gain on your infrastructure. Now, last but not least, by eliminating the need to open inbound ports, because with edge-driven, it means that instead of relying on the central server, say in the cloud, to reach out to a device or a source of data in the edge, that would require you to open a port for that server to be able to access that, or that client rather to be able to access whatever the server is on the edge. Now, if the communication is being initiated from the edge, it means that there's no need to open those inbound ports, which really goes a long way in minimizing the risk of unauthorized access, and it helps to keep the network environment secure. Now, let's move on to number 2, which is infrastructure-centric foundational principle. Now, what does it mean to say something is infrastructure-centric? So one of the advocates that talks a lot about the idea of actually building upon infrastructure or connecting your devices to an infrastructure rather than connecting them to directly is Alan Nipper, the co-inventor of MQTT and Sparkplug. Now, infrastructure-centric is the design. Infrastructure-centric is all about focusing on linking devices and applications to like a main infrastructure instead of directly connecting them to each other. So you're not connecting devices and services to applications, but rather you're connecting your devices and services and applications to a central infrastructure. So it's like having a central hub where everything meets. So instead of having this messy web of point-to-point connections, you have like a central repository or central infrastructure that all the different participants just need to plug into. So obviously this kind of like really creates a decoupled architecture that allows you to interchange all of these components, and also it makes the communication a lot smoother and the whole system runs more efficiently. So let's kind of take a look at the what that looks like to kind of like really explain this a bit more for you, what that means as far as infrastructure-centric is concerned. So if you go to the Factory Plus website, you see under infrastructure-centric, they've got this diagram that shows all the different devices connected to each other. And the idea here really is to show you how complex or how quickly this can actually become complex. In fact, they kind of like really use what they call the n-squared problem, right? So the n-squared problem refers to the quadratic increase in the number of point-to-point connections required as an architecture scales. So as you connect more devices to your architecture using point-to-point connections, your infrastructure can quickly scale, even scales quickly than you can actually anticipate up until it really becomes unmanageable. So that's kind of like really the problem that they're trying to solve here, or that they're trying to avoid by using an infrastructure-centric design as opposed to a point-to-point communication. So again, here, as you can see on this other diagram, what it means to say it's infrastructure-centric is that at the center, you've got that Factory Plus Sparkplug API, right? So all the data consumers, they connect to the MQTT infrastructure through that API. So the MQTT broker is your infrastructure. The edge devices connect to the MQTT infrastructure. You've got your Factory Plus API connecting to the infrastructure, the REST APIs connecting to the infrastructure. So instead of having all this messy web of point-to-point protocols, you've got all the different components and subsystems connecting to a centralized infrastructure, as it were. So let's move on to the third foundational principle, which is report by exception. So what do we mean by report by exception? So report by exception is a communication strategy where information is only reported or shared when there is a deviation from the expected or normal behavior. So in simple terms, it means you only send data when there is a change in its value or status. So now, picture this. Instead of constantly pinging a device for updates, we're talking potentially hundreds of times per second with no changes. Like you could literally poll for hours, especially if it's if it's a data point that really doesn't change much, right? In fact, there's actually research that shows that 90% of the variables or process variables don't really change much in a way that would require you to poll every millisecond. So instead of doing that polling, you only get information whenever there is a change in that value. So this really cuts a lot on bandwidth usage and really allows you to build a system that can easily scale. So now, again, this cuts down on network traffic and bandwidth, and also you only get to focus on transmitting the changes that matter. Now, as I mentioned earlier, Factory Plus still uses the tried and tested methods of connecting to devices and getting data, like your poll response protocols, like your OPC-UA, Modbus, right? But the idea here is all about keeping the poll response behavior as close to the edge as possible. So you've got your poll response, you've got your edge of network node connected to these PLCs, legacy communication protocols, these request response protocols, and doing the polling. And then on the other end, you've got that data being converted and being pushed into the Factory Plus network using a report by exception. So this really kind of like streamlines your communication and makes sure that you still both retain the power of OPC-UA for like your closed loop process control, and then on the other end, you're leveraging the power of MQTT Sparkplug for cloud connectivity or for connectivity to the IT systems. Now, at this stage, you're probably asking the question, what exactly are the components that make up the Factory Plus reference framework, right? Now, Factory Plus identifies a set of core components that must be present to fully implement the framework. So the first component is the identity component, which is used for ensuring unique identification of devices, users, and applications across the architecture. And then we've also got authorization, which is used for managing access control permissions for devices, users, and all applications across all components. And we've also got the directory component, which needs also to be present within Factory Plus reference framework. So the directory component, as the name implies, really is about maintaining a registry of services and devices, and also maintaining a registry of their statuses, schemas, and all the endpoints that are currently available. We'll see how those endpoints are shared shortly in one of the upcoming slides. And the other key component that Factory Plus reference framework identifies is the MQTT or MQTT protocol as being responsible for handling communication and data exchange between devices, applications, and services. And then there is a component that is called the edge agent component. So this is the component that would be responsible for capturing data at the edge and then mapping that into a schema and handling the encoding and then also the transmission into the infrastructure. So there's also the configuration store component, which is really responsible for storing and managing shared metadata for devices and applications and services. And then another key component that is required for Factory Plus reference framework is the manager component. So the manager component really centralizes device onboarding, configuration, and management. So typically, this would be like a web interface where you can do your device onboarding and stuff like that. And then we've got the commands component, right? So the commands component really deals with the handling of the escalation of commands and alerts across your architecture. And then we've got the data warehouse component, which is again, which is really self-explanatory. It's responsible for ingesting, decoding, and storing and management of all the collected data from devices and applications. Now, what's really cool about Factory Plus reference framework is that it does more than just identify the essential components that we've just described, that we've just discussed, that you need to get your framework up and running, but it actually lays out a detailed component specification that allows you to create your own plugin components that you need to integrate into the reference framework, because obviously those 9 core components, they address the key aspects of that framework, but in most cases you'll find that there are some functionalities that are not addressed by those. In fact, it's actually likely that if you're building an industrial IoT solution, you would require some functionality that is not taken care of within this framework. So the Factory Plus reference framework specifies how you can create that plugin or that component plugin. So which means that literally anyone can develop these plugins that they can then interact with the entire Factory Plus framework components in many different ways. So for instance, you could have some plugins that could be responsible for data access, and some plugins that could really just be meant for boosting the functionality of the Factory Plus core, right? So there is actually an example. I think it was for file access that the AMRC built. So if you are interested in actually developing your own plugin component, you could use that as an example to see how that could be performed. So, but I would like us to kind of like take some time here to look at that component specification to see exactly what's the composition of a Factory Plus component. How does it interchange information? What is the makeup of that component? So this is basically the specification that the Factory Plus framework puts out there as a guideline of exactly how you need to put together your component that will be able to participate within a Factory Plus reference framework. So the first key element that a component needs to have is that it needs to have a universal identifier, right? Your UUID, which is what that component exposes to other components for it to be identifiable within that architecture. Now, a key aspect here is that that component needs to have an interface, actually 2 types of interfaces. First, it needs to have an MQTT Sparkplug interface, and then second, it needs to have an HTTP interface. Now, the MQTT Sparkplug interface is used for a number of functions, but key of those functions is, first of all, the registration function. So through MQTT Sparkplug, you are able to register a component in the directory component, because remember, the directory component is responsible for keeping all identity of all components, the services, and all the endpoint URLs that that component uses. So when a component joins that network, if you are familiar with MQTT Sparkplug, you'd know that it has got what is called a birth certificate, a mechanism whereby every Sparkplug participant within an MQTT network needs, whenever it joins an MQTT network, it needs to send out a birth certificate. So a birth certificate basically is a way of announcing to the rest of the network participants to say, these are the metrics that I'm going to be publishing into the network. This is my identity. and so on and so forth. So basically, it helps all the other participants prepare to receive that information because it specifies all the data types and everything like that. So now, as part of that birth certificate of announcing a component to the directory component, it also needs to include its HTTP endpoint in that birth certificate. So that's really a smart way of including that, because it's a way of discovering the HTTP endpoint, because when you plug the component into the MQTT network, this automatically gets published into the directory component. So even if your component was previously unknown to the rest of the network, as soon as you plug it in, Sparkplug allows it to announce itself, and then through announcing itself, it then also includes its HTTP endpoint, which you can then also going to use for other functions, because there's stuff that you can use to via an MQTT Sparkplug connection. For example, here you can use some notifications, data changes, metric changes, and on so forth. But if you need to transfer large amount of data, you need to use that HTTP interface as far as the Factory Plus reference framework is concerned. And also just like pretty much using it for a request response data access, right? Because there's some scenarios where you want to like have a synchronous communication. Maybe you're sending an instruction and you want to wait to receive feedback on the success of that instruction. So you need a request response model of communication for that. So that's what the HTTP interface would be. So basically, a component needs to expose both those interfaces. So these are the key. Again, for more details, you need to check out the framework on the Factory Plus website, where you can really get a more detailed breakdown of exactly what the component specification really is. So, but now I would like us to kind of like really just go over the different components. So we've identified, we've talked about the components that the core components that Factory Plus really identifies as being the core elements that really need to be present for you to fully implement the Factory Plus framework. So again, these are explained in detail on the website, but here what we're going to do is kind of like going to talk through all 9 of them to kind of like give you an idea of what they really are all about. So the first one that we spoke about is the identity component. So Factory Plus uses Kerberos as its identity provider. So Kerberos is like it's an authentication, it's a network authentication protocol that was developed at MIT, and it is designed to provide strong and secure authentication for client server applications. And the key features of Kerberos include mutual authentication, a single sign-on, symmetric key cryptography, ticket-based authentication, and it also allows you to scale your identity across your architecture. So the next key component that is specified by the Factory Plus reference framework is authorization. So again, the Factory Plus framework specifies or identifies the authorization component as another important piece of the puzzle. So the authorization component is basically responsible for controlling and restricting access to resources based on the permissions that you give to the different actors or participants within your architecture. So to manage these permissions, it uses access control lists, right? So access control lists really provide a flexible way to set up and handle access control policies. So the Factory Plus authorization component can be broken down into the following components, which is principals. So the principals are entities that interact with the architecture and the entities that request access to its resources. And then the other component, the other element is the access control list, as already we've spoken. So access control lists are data structures that specify the access permissions for resources in the architecture. And then there is the resource management element. So basically the resources in the architecture are managed by different components, and each component is responsible for defining its own access control list. And then there is also access control enforcement. So when a principal attempts to access a resource, the authorization component checks the corresponding access control list to determine if that action is allowed. So we've also got the directory component. So the Factory Plus reference framework identifies the directory component, which is really a component that is designed to help applications, users, and other components find the devices and services they require. So again, if you remember from the example or the specification of a component that I spoke about, whereby you need to announce the services that you are capable of performing via that birth certificate. So now by monitoring that Sparkplug birth and death messages, the directory component is able to keep a comprehensive registry of devices and services, including things like their current status, the schema that that component is using, and endpoints that component is using, which really makes it easy for applications to locate all these different components. So there is also a configuration store, right? So configuration store component really serves as a framework, aware central repository for applications that are utilizing Factory Plus to store data and things like settings and other information that are associated with the Factory Plus entities. So storing data centrally facilitates the sharing of metadata among the different applications without duplicating definitions within applications, which really allows it to eliminate the need to incorporate information in the Sparkplug birth certificate, right? Which really is going to make it difficult to increase the size of that Sparkplug metric or that birth message. So the configuration store component entries are served as JSON documents. So again, this really is a summarized version, just to kind of like give you a picture to help you then go and take a deep dive into that specification, into that reference framework to understand it in more detail. So again, as a reminder for those who might be just joining, so this is a pre-recorded session. But if you've got any questions, feel free to drop them in the chat. I will be able to get to those as soon as I'm available. So I'm currently not available away for a speaking session, which I'm really looking forward to. So the next component is the manager component. So the primary function of the Factory Plus manager component is to kind of like offer an interface for configuration, storage, and delivery of edge component configurations to the respective edge agents. So the Factory Plus has got like a straightforward API specification, right? So the implementations of the manager components are places where you can then incorporate the user-friendly controls for interacting with other framework components, which really makes it like a central hub for user engagement with the overall architecture. Right, and then the other core component that we spoke about is the command component, which is really kind of like a mechanism for clients to request Sparkplug command messages to be issued to other clients. So in their own words, really, the command component really offers a mechanism for clients to request Sparkplug component messages to be issued to other clients, given obviously the appropriate authorization. So the Sparkplug specification indicates that only the primary application is responsible for transmitting commands, but the precise methodology and timing for this process are not explicitly defined. So it is inferred that applications must interface with the primary applications to request commands, and as such, the commands component provides the implementation for this specific aspect of the primary application's functionality. So again, for those who might not be familiar with MQTT Sparkplug, MQTT Sparkplug, one of the key components of an MQTT Sparkplug network is what is called a primary host, which is typically a SCADA system. So that's the one that is capable of executing commands. So all the devices, all the edge of network nodes that join an MQTT Sparkplug network if they are capable of executing commands, they need to announce to that primary host to say, these are the commands that I'm capable of responding to, and this is what you need to do to invoke those commands. So basically, the commands component is that implementation of that Sparkplug primary host, which is going to listen whenever a new component joins. When it announces that it's got some commands that it is capable of executing, that commands component will take note of that, and then it will be responsible for issuing those commands. So in a nutshell, it is an implementation of that Sparkplug component. And then finally, we've got, okay, so I think we've got still some more to go, not finally. We've got the data warehouse component, which serves as the storage hub, right, for all metrics that are being generated within your architecture. So basically, the data warehouse listens in on all the messages that are transmitted from the edge, and then it persists those messages in a structured format according to whatever schema is being used. And then again, we've got MQTT being a key component, as already mentioned. So MQTT, again, for those who are not familiar, really it acts as a central communication hub through which all MQTT messages go through. So in this instance, the MQTT component is that hub through which all MQTT communications between the Factory Plus components happen. So Factory Plus does not prescribe a particular specification for the MQTT component, as long as it is compatible, it is MQTT 3.1 compatible. But Factory Plus framework uses HiveMQ. So if you're using HiveMQ, the plugin, Factory Plus plugin, will handle a lot of configurations automatically for you. So we've got the edge agent as the next component, core component of the Factory Plus framework. So again, in their own words, the edge agent really is the workhorse of the Factory Plus reference framework. It operates at the periphery, and its role is really for gathering data from devices, normalizing the data into data schemas, converting the data into packets, MQTT Sparkplug messages, and then transmitting those messages into the MQTT component, right? And then finally, we've got the data schema component. So again, I mean, without proper context, if you would know within industrial IoT or connected factory, without the proper context and structure, the data that you collect is really not of much use for you to make sense of. So if you're collecting data from multiple device types and variants of devices and putting that into a common architecture, there is the challenge that is always present of exactly how do you create context out of all this data that is usually unlabeled. Sometimes it is without context, it is unstructured, and so on and so forth. So to address this issue, Factory Plus includes a data schema specification that allows new and existing models to be represented across the framework in a modular, reusable, and consistent format, right? So this ensures that the data is gathered in a standardized manner, and it eliminates the need for manual data processing, which is typically the case right now. If you need to integrate data from PLCs, you need to do a lot of heavy lifting manually to actually contextualize that data. So Factory Plus, through this data schema component, does that standardizing of the data schema. So I mean, it is also important to mention that here Factory Plus schema allows you to create new models. So you can create new models using the Factory Plus data schema, but they make the point of pointing out that this is not a way of replacing some specifications that already exist around data modeling, for example, Opus UA companion specifications or MT Connect. Rather, this is a way of providing a guideline of how to use a JSON schema to create your own custom models that that will be understood within a Factory Plus reference framework. So it turns out that the AMRC has also developed a collection of models that are utilized internally and have been released as open source resources. So again, feel free to check out the reference framework for more details around that. So the Factory Plus schema uses JSON schema version 2020-12, which is a vocabulary that enforces the structure and enables the validation of these JSON components. So maybe to kind of like close this off, let's quickly take a look at what that data schema specification looks like. So if you go to the reference framework here, you can see all the stipulations that Factory Plus schemas must adhere to the following rules, right? So this is all the rules that you can go through it. For example, all schemas again must adhere to this version of JSON schema. All schemas must use integer version number to control the schema version, and so on and so forth. And then also it goes on to show how these metrics are defined, right? So you can also check out these examples to see exactly how these metrics are defined, and also what needs to be included, breaking down the schema UUID, which is part of the schema definition, and also for reusability, how to take care of that. So there's also examples on that, and then also composition versus inheritance, representing Sparkplug metrics, how to represent Sparkplug metrics within that data schema. So all of that information is available, which you can check out again under data schemas on this Factory Plus reference framework webpage. And then there's also an example that you could follow here. So with that, this brings us to the end of our session today. I hope you really found this useful. So again, if you new here, please make sure that you subscribe to the YouTube channel. Again, we do this every week, every Thursday at 6 p.m. Central European time, Central European summer time. We get to explore all the different tools and techniques that are used for developing the connected factory. So again, I hope this was really useful for you. Let's meet next week where I hope to be live, and then we can kind of like continue our interactions. So thank you again for joining, and really appreciate your time here today. And feel free to reach out to me if you've got some more questions, and also you could go and check out the Factory Plus webpage for more details on this really impressive smart manufacturing reference framework. So thanks again, and cheers.